So our answer won't necessarily be the answer. You'll have to go a little step further on these next two. All right, so next one, a quadratic inequality says it's of the form of an x to the second. So this is our regular quadratic equation we studied in the past, where a, b, and c are some real numbers. You have a variable squared, and sometimes the x is there and then the constant. Okay, so you must solve these as you did quadratic equations. And this will give you boundary lines that then you will follow up and test the regions. Like I said, you have to go a step further. Show you what I mean. Example 1. Okay, so it's already kind of in our standard form here, isolated, the 0, x squared, x, and constant. So we'll factor that as we did other quadratics, or if you don't like to factor, you can still use the formula here. Most of these will factor though. So you break it apart, set each part equal to 0. And you get your two quadratic solutions. But like I said, I don't really know what to do with those solutions, whether it's the region between those or it breaks apart to the side regions. So what we do is we make a number line and say we've divided the number line into these areas. We've got a -3 and a 4 that are just cutting the number line into the region. So I'm either going to shade the stuff in between it or the stuff on the outsides of it. But I don't know until I check into this. So I'll take a test point out in this area. Now don't use -3, okay? A lot of times students see those and they want to use those numbers, but that's just your boundary. Use something beyond it, over out in this area, like -4. Exactly what you said, that we're looking for what solves this. And if it does, if this region is a solution to be shaded in, then any number I pick from this should work. So take any number, but what's your favorite number on the other side of -3? Anybody?
-4.
-4 will be fine. -4, and you can plug it in for the x here or here in the factored form. You get the same result. So let's say I do this because it's a little easier in the factored form. -4 minus 4 is -8 times -4 plus 3 is -1. Is -8 times -1 less than 0? That's our question. And it is not. That would be a +8, which is not less than 0, so do not shade that region. Then check the middle region. It's probably going to be the middle. Like I said, it's either the outside parts or the inside part. So I feel like this is the answer, but we'll double check. My favorite number between -3 and 4 would be 0, but you can pick anything between there, test it in the original problem or in its factored form. So 0 minus 4 times 0 plus 3, that'd be -4 times 3, which is -12, which is truly less than 0. That's a true statement, so that means this region works, so I shade that. And then you could be just absolutely sure by checking the third region, but I'm going to save time and say that's the answer. So the answer is between -3 and 4, no line under that, so they're both parentheses.
So you can't have two shaded areas?
And some on these, really the recommended way to solve them is to actually go through and check each region, but I'm just telling you it's always every other one. So it's either the inside part or it'll be these two outside parts.
So if it's not the middle, it'll be both?
It'll be the outsides, yes. That's true. All right, and I think our next example that happens when we check it lines up in the outside regions. On example 2. Okay, so on this example, we're going to do the same process. Notice it's already isolated in standard form with a 0. Now, if you have one in your homework, that's not. Make sure you rearrange it first. Get it in its standard form. And this keeps us in our factoring process. You know how we started out the semester that way. We were practicing on the factoring, so we keep using that. So hopefully you're conquering that, feeling really good about that now, and breaking these down. So 2x times 1x is 2x squared. I know I need different signs to get a -12. I think it's 6 times 2. That will be 2x. No, it's not. It's on your paper, isn't it? What works? 3 and 4. Thank you. 3x minus 8x would be -5x. So I need to fix my signs. like so. So check that out, and that should work. Then we set each part equal to 0, which gives me my two solutions of 3/2 and -4. And like the last one, remember that only gives us our boundary lines to cut the number line into pieces, 3 regions in this case, and then we'll check to see which regions work. Now, here's what my strategy is. I always check the 0, and then if I know I get that one right, it's the easiest one to check. I know it's the other ones. So I would take the 0, check it in, 4x. 2 times 0 minus 3 is -3. 0 plus 4 is 4. -3 times 4 is -12. -12 is not greater than or equal to 0, so that does not work. So now I'm feeling it must have been these two outer regions. But like I said, I'm still recommending that you double check that with a test point in these two areas. This time I have a line under it, so I will use brackets. So my solution is 2 different pieces. It's this piece, -infinity to -4, bracket, parentheses. Now since there's 2 parts, we'll use a U for union that adds these 2 answers. 3/2 to positive infinity. Okay, any questions on that?
Yeah, why don't you start with infinity first on that one?
You always say whenever I'm naming this section, I say what's to the left and furthest to the left. You get it in order, left, right order. So to the left, it's -infinity, to the right.
And the other one furthest to the right.
And then I read this region right. Okay, other questions?